What scientists think is the brightest object ever found in the universe, consumes the equivalent of one of our suns each day.
Recent discovery from the field of space exploration has surprised the astronomy community. A huge star has been found, and it's now considered the biggest star in the universe. This star is much larger than our sun, and its big size pushes the boundaries of what we understand about size and scale. So come with us as we explore the terrifying discovery of WOH G64, the universe's new biggest star. Billions of stars beyond our gaze. When we look up into the sky, we can see thousands of shining stars. However, what's visible to the naked eye is just a fraction of what's out there. With powerful telescopes, we can explore our galaxy, the Milky Way, and discover billions more stars. Estimates suggest that the Milky Way alone contains between 100 to 400 billion stars. If we extend our view to neighboring galaxies and beyond, the number becomes endless. Even our nearest star, the Sun, seems big as it rises and sets every day, dominating the solar system. Surprisingly, though, the Sun is just an average-sized star. There are stars much larger than our Sun, remarkably larger, not just by a little, but so large. When we wonder about the size of stars, it's crucial to consider whether we're referring to their mass or total volume. Mass indicates the amount of matter a star contains, while volume measures the space it occupies. Interestingly, the most massive stars may not be particularly large in terms of physical size, and the brightest stars might have less matter despite their significant size. As stars age, they tend to lose mass, a phenomenon also occurring with our Sun. In about 5 billion years, the Sun will transform into a bloated red giant, expanding to cover the orbits of Mercury, Venus, and possibly Earth. While this transformation will make our Sun bigger, other stars in the universe surpass its size by a considerable margin. Before delving into the stars with the most significant physical dimensions, let's examine the current title holder in terms of mass, BAT 99 to 98. This star boasts an estimated mass of 226 times that of our Sun, meaning it contains the equivalent of 226 suns worth of matter condensed into one celestial body. The process that led to BAT 9998 acquiring such immense mass remains not entirely understood, but scientific models propose that it may result from the merger of two stars. Interestingly, despite its colossal mass, BAT 9998 is relatively young at approximately 7.5 million years, a stark contrast to the Sun's age of 4.6 billion years. Adding to its uniqueness, the star is actively shedding mass at a rapid pace, having already lost an amount equivalent to 20 suns since its formation. Due to its intense activity, scientists predict that BAT 9998 will dramatically meet its end, likely culminating in a supernova that leaves behind a black hole. However, regarding sheer physical size, BAT 9998 is not the champion. With an estimated radius of 37.5 times that of the Sun, it doesn't come close to claiming the top spot. If you were to search on Google for the largest star in the universe, you would likely encounter information about WOH G64, a red supergiant. Until recently, WOH G64 held the record for the largest star by physical size, initially measured at around 1,700 times the size of the Sun. However, a more accurate measurement of WOH G64's distance from Earth revealed an adjusted estimated radius of 775 times that of the Sun. This correction significantly altered its standing, removing it from the top spot. Despite its remarkable size, WOH G64 no longer ranks among the top 80 largest stars, bringing it closer in size to well-known stars like Betelgeuse or Antares. Even with this, WOH G64 remains incredibly massive, though not the largest in the stellar lineup. Exploring the mystery of Stephenson 218 and WOH G64. There's another star that was thought to be the biggest just a couple of years ago. It's called Stephenson 218, and some scientists believed it might be a huge red hypergiant star. People estimated it to be so big that if you put it in our solar system, it would swallow up Saturn. If you could zoom around it at the speed of light, it would take almost 9 hours to complete one loop. To put that in perspective, going around our sun at the same speed would only take 14.5 seconds. Now, some estimates suggest Stephenson 218 is about 2,150 times the size of our sun. But there's a theory about stars that says there's a limit to how big they can get. According to this idea, stars can only grow to about 1,500 times the size of the sun. So maybe Stephenson 218 was overestimated. This could be because we're not sure about its distance from Earth. It could be off by as much as 50%. There isn't a clear equation to determine how big a star can get. It depends on things like mass, composition, evolutionary history, and how strong its stellar wind is. For stars like Stephenson 218, their outer atmosphere could keep expanding without a limit. But at some point, this outer gas merges with the space between stars and can't really be counted as part of the star's surface anymore. Measuring the size of giant stars is tough. They're really massive, thousands to millions of times bigger than our sun, very far away, and bright. They also have huge atmospheres and photospheres that change a lot and are often covered in big clouds of dust. So figuring out their true size is a big challenge for astronomers. Despite these challenges, scientists try to estimate star sizes using factors like distance and the surroundings. By combining these measurements, they can get estimates that fall within a certain range of confidence. Based on the best measurements we have, the current record for the largest star in the known universe goes to a red supergiant called WOH G64. It's situated around 160,000 light-years away in a nearby galaxy called the Large Magellanic Cloud. WOH G64 boasts a vast size, approximately 1,540 times the radius of the Sun. To put this in perspective, if it were to replace the Sun in our solar system, its immense reach would extend to engulf the orbits of Mercury, Venus, Earth, Mars, and even Jupiter. This expansive measurement aligns with the theoretical growth limit and resonates with findings from other large red supergiants discovered elsewhere. This massive star is likely in the later phases of its stellar evolution. Stars of this kind have depleted their nuclear fuel, causing their outer layers to expand and transforming them into true cosmic giants. Adding to its grandeur, WOH G64 is enveloped in a torus-shaped cloud of dust spanning about a light-year in diameter. This cloud comprises materials expelled by the star. Interestingly, calculations suggest that if all the material in the torus cloud were gathered, it could replicate our entire solar system 9 times over. The question arises, is WOH G64 the largest star in the known universe? While some studies propose an estimated radius of 2,575 times that of the Sun, surpassing even Stephenson 2:118's possibly overstated size, conflicting measurements persist. This larger measurement would easily engulf Saturn's orbit, and circumnavigating it at the speed of light would take nearly 10.5 hours for a single loop. To put this in perspective, light from the Sun reaches Pluto in just 4 hours. While it is evident that the universe contains truly large stars at various evolutionary stages, identifying the largest remains uncertain. Ongoing advancements in observational techniques and technology hold the promise of refining measurements, providing astronomers with a deeper understanding of these cosmic giants, while G64, with its large dimensions, stands as a candidate for the title of the largest star ever observed in the known universe. But let's not conclude so early because, with the introduction of the James Webb Space Telescope, everything is about to change. Exploring the potential birth of stars from dark matter. The James Webb Space Telescope recently discovered something unexpected. It might be a new type of star born in the early universe. And what's surprising is that it could be powered by dark matter. About 84% of the matter in the universe is dark matter, which doesn't emit or absorb light. Astronomers can't see or detect it directly. Dark matter supposedly affects visible matter, radiation, and the structure of the universe. Currently, detectors are searching for weakly interacting massive particles, the potential building blocks of dark matter, but nothing has been found yet. A recent study suggests that dark matter might create streams radiating from Earth, but it hasn't been proven. Now back to the idea of dark stars powered by this mysterious dark matter. The concept of such stars is still theoretical, and scientists are unsure if the images from James Webb actually show them. However, if one of the three candidates turns out to be this new type of star, it could provide insight into how stars formed in the early universe and reveal more about dark matter, possibly explaining the origin of supermassive black holes. The term dark star was first mentioned in 2007, suggesting they could be among the first stars in the universe, powered by heat generated during dark matter interactions rather than nuclear fusion like our Sun. Experts believe dark stars would look unusual, possibly originating from clouds of hydrogen and helium influenced by excess dark matter. While the nature of dark matter is unknown, there's a theory that dark matter particles can interact, destroying each other and producing light and heat. This heat could prevent the condensation of hydrogen and helium clouds, preventing the formation of hot cores like those in present-day stars. Theorized dark stars could be immense, potentially 10 times wider than our planet's orbit around the Sun. They might also be millions of times more massive than our Sun, with light billions of times brighter. This could explain why James Webb detected them. Scientists studied over 700 objects in early galaxies from the first 100 million years of the universe's existence. The light from these ancient objects is red-shifted due to their unimaginable age. The team picked 4 extremely red-shifted objects, likely tiny galaxies from the early universe. Unfortunately, the resolution of James Webb isn't sufficient to confirm whether they are galaxies or large, super-bright stars due to their considerable distance. Betelgeuse is a big star in our galaxy, much larger and brighter than the Sun. It pulsates, getting bigger and smaller. At its peak, it's 800 times its average size. If it were a bucket, it could fit about 300 million suns, even though it's only 17 times heavier. Traveling to Betelgeuse with the current spacecraft would take almost 8.7 million years. This star has an interesting history. It started as a beautiful nebula, a colorful cloud of space dust. Over time, it shrank, and a nuclear reaction in its core created the star. At first, Betelgeuse was massive and hot, but stable. The heat and energy from nuclear reactions pushed the star's walls, causing it to expand. Gravity also pushed on it, but when these forces balanced, the star remained stable. As the star used up its fuel, which is helium and hydrogen, heavier elements joined the nuclear reaction, releasing more energy than gravity could hold. So Betelgeuse started expanding and will continue until it exhausts its fuel. After that, gravity will win, and the star will shrink, leading to a supernova explosion. Betelgeuse might explode within the next 10,000 years, or some scientists say it could take longer. There's a possibility it could become a black hole, but it's more likely to turn into a white dwarf, gradually fading away. A recent study suggests Betelgeuse might explode within our lifetime. It's a red giant with about 300 years of fuel left. Once it burns through this fuel, its core will collapse, possibly forming a black hole. If it goes supernova, it'll be visible from Earth and shine as bright as the full moon for several weeks. Despite being 650 light-years away, it won't harm Earth. Betelgeuse's pulsations and odd behavior hint at its stage in life. If it's burning carbon, the end is near, possibly within a few thousand years. Carbon exhaustion could happen in about 300 years, leading to a supernova explosion. Black holes are mysterious and powerful objects in the universe. They can absorb entire galaxies and bend space and time. Let's explore more about them. Quasi-stars and the early cosmic drama. You see, the universe is filled with wonders, and among them, the black hole star stands out as one of the most impressive. It's a supermassive force capable of bending the laws of physics, posing a true problem for scientists. No wonder it captures the imagination of science fiction writers. Also known as a quasi-star, it's a hypothetical type of extremely massive and bright star that may have existed in the early history of the galaxy. Unlike modern stars, these quasi-stars were powered by nuclear fusion in their cores, drawing energy from material falling into a black hole at their center. Similar to regular black holes, these stars have the ability to pull in anything that comes too close, including stars, dust, and even entire galaxies. But how does a star emerge from a black hole? And how do they coexist? Let's first understand how black holes are born. It begins with a supermassive star, several times more massive than our sun, burning bright until it exhausts its fuel. In its final moments, it undergoes a massive explosion called a supernova. During this event, the outer layers fly away, while the core collapses under its gravity, forming a black hole. Now, let's delve into quasi-stars. They could only have formed in the early universe before hydrogen and helium were mixed with heavier elements. Quasi-stars are giants, dwarfing even the largest known modern stars. Imagine a protostar so massive that its core collapses into a black hole. But unlike a regular supernova, the outer layers are massive enough to absorb the energy without being blown away. The result is a star with a black hole in its core, weighing from 1,000 to 10,000 solar masses, 14,000 times bigger than our sun. These celestial titans emit a tremendous amount of energy, making them appear like small galaxies. Quasi-stars have a relatively short lifespan of around 7 million years, during which the black hole at their center grows significantly. However, there's currently no observational evidence for the existence of quasi-stars, as they are believed to have existed a very long time ago and might have been rare and challenging to detect. Scientists theorize about quasi-stars to explain the early formation of supermassive black holes at the centers of galaxies. These mysterious objects might have played a crucial role in shaping the universe and influencing the evolution of galaxies. While there's still much to unravel in this cosmic mystery, advancements in technology and scientific exploration are bringing us closer to understanding the secrets of these celestial giants, probing black holes with X-rays, infrared, and radio waves. Gravitational waves are essentially like ripples in the fabric of space-time, caused by the movement of massive objects. Albert Einstein predicted these waves back in the 20th century, but it wasn't until 2015 that we finally detected them. The breakthrough came when we observed the collision of two black holes. This discovery confirmed that black holes can merge and are potent sources of gravitational waves. Scientists believe that by studying these waves, we can gain insights into how black holes form and grow. It's comparable to trying to identify a criminal by their fingerprints. For instance, if a black hole is situated near a star, scientists can observe the distortion of the star's light as it gets pulled toward the black hole. To aid in these observations, we utilize various technologies such as X-ray, infrared, and radio telescopes. This comprehensive approach allows us to study black holes in diverse ways and at different stages of their existence. In simpler terms, scientists are diligently working to unveil the secrets of these celestial giants. We are actively developing new telescopes to search for primordial black holes and to comprehend the complex relationship between black holes, stars, and dark matter. Remarkable discoveries are being made, much like our exploration of gravitational waves. Picture gazing at the night sky and spotting stars that aren't just big, but are absolutely massive. Scientists have been utilizing the James Webb Space Telescope to delve into the early stages of the universe. In the course of their exploration, scientists made a remarkable find: ancient stars that are a staggering 10,000 times larger than our sun. Yes, you heard it right, 10,000 times. These colossal entities were among the very first stars to come into existence billions of years ago. Imagine a globular cluster as a huge space gathering, with each group comprising an impressive 100,000 to 1 million members. These clusters resemble giant family get-togethers where all the stars are born around the same time. However, what sets these recently discovered giants apart is their cores, or central parts, which are significantly hotter than what we observe in stars today. Scientists believe this intense heat may be a result of hydrogen burning at extremely high temperatures, akin to a galactic barbecue party. Within these globular clusters, something captivating unfolds. Smaller stars collide with the supermassive ones, gaining extra energy like a power-up. However, there's a twist. Most of these clusters are now aging, and the supermassive stars vanished long ago. We can only discern hints of their existence in the clusters we observe today. Scientists study them by examining the mysterious traces of their grand presence. The discovery of these monster stars holds immense significance for our comprehension of the universe. If scientists can amass more evidence to confirm their existence, it would mark a major breakthrough. This discovery could enhance our understanding of how globular clusters and supermassive stars form in general. However, that was only the first fascinating discovery of last year. The subsequent one is somewhat disheartening. Cassini's finale and the ephemeral beauty of Saturn. Consider the magnificent rings that make Saturn look so elegant. Well, they might vanish in the not-so-distant future, astronomically speaking. NASA's Cassini mission, which explored Saturn from 2004 to 2017, gathered compelling data about the rings. In the remarkable finale of the Cassini mission, as it executed impressive maneuvers around Saturn, scientists observed a surprising phenomenon. The majestic rings of Saturn were shedding mass rapidly, with tons of material disappearing every second. This suggests that the splendid halo surrounding Saturn may only endure for a few 100 million more years. While this might seem like a vast time frame from a human perspective, in the vast expanse of the universe, it's merely a fleeting moment. The crucial insight gained from this observation is that extensive rings like those of Saturn are not everlasting. They gradually diminish over time. Interestingly, scientists propose a captivating theory about the fate of other ice and gas giants in our solar system, such as Uranus and Jupiter. Saturn's rings primarily consist of ice, along with a sprinkling of rocky dust originating from asteroids and tiny meteoroids colliding with celestial objects. This creates a celestial snowstorm of icy particles and space debris. Furthermore, research indicates that Saturn's rings formed long after the planet itself, still in the process of formation during the era of roaming dinosaurs on Earth. In astronomical terms, these iconic rings are relatively young, being only a few 100 million years old. This discovery has sparked curiosity among scientists, as it suggests a dramatic event occurred in Saturn's past to give rise to this stunning, icy disk. However, the specific cause of the rings' formation and the reasons behind their breathtaking structure remain a mystery, presenting a compelling puzzle that scientists are eager to unravel. On a more positive note, there is noteworthy news from the realm of space exploration. Recently, scientists have been delving into the study of one of the most remote galaxies in the universe, uncovering a remarkable discovery: organic molecules. This particular galaxy, designated as SPT 041-1847, resides a staggering 12 billion light-years away from our humble blue planet. Just try to fathom that immense distance. It stands as the farthest known galaxy where complex organic molecules have been identified. Gazing at this galaxy is akin to peering into the infancy of the universe, as we do not know its current appearance. The light reaching us originated when the universe was a mere 1.5 billion years old, an extraordinary opportunity to witness the past. The scientists stumbled upon a substance with a complex name, a polycyclic aromatic hydrocarbon molecule, or simply a PAP molecule. Curious about what this entails? Interestingly, these molecules can be found right here on Earth, such as in car engine exhaust or even the smoke from forest fires. Comprising chains of carbon atoms, PAH molecules serve as the fundamental building blocks for life. Further revelations show that the gaseous matter in that galaxy is brimming with heavy elements, a significant revelation implying the presence of numerous stars that have existed and contributed to the creation of these remarkable elements. This suggests the potential richness of various other elements in this galaxy. This groundbreaking discovery not only opens up a realm of possibilities, but also raises a multitude of intriguing questions. How did these molecules form in such a distant galaxy, and what could have transpired over time? Is it conceivable that these organic molecules evolved into life? We are merely scratching the surface of the incredible phenomena awaiting exploration. Now, you may wonder how scientists managed to make such a discovery from a galaxy so far away. The key lies in the remarkable James Webb Space Telescope, Einstein rings, and the surprising discoveries beyond. The James Webb Space Telescope possesses unique observational capabilities, granting scientists the powers needed to explore and uncover the mysteries of the universe. While examining the distant galaxy, scientists faced a challenge. The light emanating from those remote objects was extremely faint, making detection difficult. However, they devised a clever solution using a phenomenon known as gravitational lensing. Picture two galaxies aligning perfectly, akin to a well-planned photo shoot. The light from the distant galaxy, the one in the background, travels towards us, passing through the foreground galaxy, acting like a colossal space lens. Here's where the magic happens. The gravitational pull of the foreground galaxy bends the light, acting like a magnifying glass and making it larger and brighter. Essentially, it's like having a cosmic zoom lens for our telescopes. This bending of light results in a fascinating formation called an Einstein ring, resembling a halo or a luminous ring enveloping the foreground galaxy. This gravitational lensing isn't just a cosmic trick. It's a showcase of nature's extraordinary capabilities. Thanks to these captivating Einstein rings, scientists gain clearer insights into distant objects, unraveling shocking details about the universe. Through this method, they've successfully uncovered hidden chemical interactions from early galaxies. A truly remarkable feat. The scientific community is buzzing with curiosity about this unexpected discovery. The revelation of complex organic molecules in an incredibly distant galaxy has exceeded their expectations. This discovery might just mark the beginning of a shocking cosmic journey. As space explorers, we're encouraged to keep our eyes fixed on the stars, for the universe is brimming with surprises. Who knows what other mind-blowing revelations await us out there? But is it possible for a planet to be larger than its parent star? Well, if we're talking about a star like our Sun, it's highly improbable. However, let's consider a different scenario involving a white dwarf. A white dwarf is what remains after a star, similar to our Sun, exhausts its outer layers, leaving behind only the core. Typically, a white dwarf is roughly the size of our home planet. In the event that a star had a planet larger than Earth before it reached the end of its life cycle, it's conceivable that such a planet could endure the ensuing celestial turmoil. In fact, we have identified planetary systems where a planet is larger than its associated star. Nevertheless, there's a significant drawback to this situation. Unlike our Sun, a white dwarf is no longer a living star. It doesn't generate energy, but instead exists passively, gradually cooling over time. Consequently, such systems might not be suitable for direct comparison, as our Sun continues to actively fuse hydrogen into helium in its core, a process it has sustained for over 4 billion years and will continue for the next 7 or 8 billion years. The Sun, being 10 times wider than the largest planet in our solar system, Jupiter, poses a limit on the size of planets in relation to stars. Attempting to increase the mass of a planet beyond a certain point would result in it getting smaller, not larger. Thus, while it appears theoretically conceivable to have a planet larger than the Sun, The practicality of finding such planetary systems is challenging. Additionally, there are dim red dwarf stars, the smallest stars barely capable of maintaining fusion in their cores. Recent astronomical discoveries have identified the tiniest stars known, which are smaller than Jupiter. If astronomers' conclusions are accurate, these diminutive stars could barely fuse hydrogen into helium, requiring about 0.077 times the Sun's mass, or the equivalent of 75 Jupiter masses. Despite their small size, they still qualify as real stars. In contrast, some of these stars are only the size of Saturn, suggesting that stars theoretically could have planets larger than themselves. However, in practical terms, finding such planetary systems remains a challenging quest. We have discovered and closely studied numerous exoplanets, which are planets orbiting stars beyond our solar system. Our observations indicate a wide variety of characteristics among these distant worlds, including differences in mass, size, brightness, and more. However, a prominent pattern emerges. Red dwarf stars, the most common type in our galaxy, typically lack gas giants in their orbits. When red dwarfs do have planets, these are usually smaller, rocky worlds similar to Earth, commonly referred to as terrestrial planets. An illustrative example is the red dwarf named TRAPPIST-1, which boasts 7 Earth-sized planets in its orbit. Nevertheless, the presence of gas giants around red dwarfs remains exceptionally rare. Among the myriad of diminutive stars, only a minute fraction, perhaps 1 in 100, can claim such a planetary companion. It's crucial to note that this estimation may further diminish as our research relies on potential planets that have not yet been definitively confirmed. Compounding the challenge, the smallest red dwarf stars also happen to be the least luminous, rendering them incredibly challenging to detect. As a result, determining the existence and nature of planets around these stars poses significant difficulty. While there remains a possibility of systems where a planet surpasses its parent star in size, statistically such occurrences are highly unlikely. Red dwarfs, despite being relatively small in size, constitute a substantial majority of stars in the galaxy, making up approximately 70% of the stellar population. Even though the tiniest red dwarfs are somewhat uncommon, their mere abundance implies millions or possibly billions of them scattered throughout the galaxy. If even a modest fraction of red dwarfs host gas giants, it implies the potential existence of numerous such systems overall, some of which may feature planets larger than the red dwarf itself. If you found value in this video, don't forget to show your support. Hit the like button, share your thoughts in the comments, and subscribe for more awesome content.